Yes, thanks for your generosity as far as time is concerned. Yeah, so without wasting any more time, we'll get off the mark. I would just set the context in letting you all know what is the quantum computing scene and what is happening in AI and how the two are getting along together before we get on to the discussion. Now, the last 2 days ago report in UNA and a lot of other channels says that China has succeeded in training its billion parameter AI model on its 72 qubit origin Wukong quantum computer. People are still, debating upon the veracity of this report. But whatever it might be, I would say the love marriage of AI and quantum has happened. That's what it signifies. Arranged marriage has been happening since a long time, and we'll discuss upon that how. But this is what is ultimate. And it has, that the report says that it has resulted in improvement in performance by 8.4%. And the most shocking thing is that reduction in parameters by 76%. There's something like what has happened in DeepSeek. So, having said that, a lot of developments have been happening in AI quantum computing. And why a quantum computer is being favored today is because if you see big supercomputers like the Exascale supercomputer, the biggest one is Frontier in US. Then you have the Aurora, then El Capitan, and then you have one 400 petaflop supercomputer in Finland, and so on and so forth. They are big guzzlers of power. You know, they are guzzlers, I mean, in the sense that they take up about close to about 100 megawatts of power. And compared to that, the power expenditure in a quantum computer is in the order of kilowatts. And it can process data and certain kinds of problems much faster than what a classical supercomputer can do. Of course, it is said that a quantum computer will not exist on its own till a long time to come, and it has to function in conjunction with a supercomputer. So it has to be a hybrid computing environment where a quantum computer will function as an accelerator to a supercomputer. And that's what a lot of efforts are going on in the world. In what we have heard, of course, IBM is there. It's offering its quantum computers on the cloud, and you have the Amazon bracket. You have these kind of efforts happening in institutions like LRZ in Munich. There is an institute in Zurich, both in Germany, in Barcelona Supercomputing Center in Spain, and in US. And you heard Dr. Chaudhary as to how the scenario is in India. Although we've not been able to develop, from the fundamentals, grounds up a quantum computer, but we do have simulators. We do have a large quantum computing awareness amongst the researchers and students. And we have already developed things like a simulator, which is called a QSIM. It has been done by ISC Bangalore and CDAC and IIT Roorkee, and it is available on the cloud on smaller supercomputers in a 18 qubit and 15 qubit kind of scalability. So these kind of things are available, and there is a big machine called Param Siddhi AI in CDAC, on which you can simulate this kind of a thing, and you get a better capacity of around 32 qubits for people to play around with. So there is a large scope of in India to develop algorithms, use cases in various domains where it is possible and theoretically possible to actually have more efficient use cases, like in healthcare, in optimization, logistics, in fintech, of course, in cybersecurity, and to play around with these kind of facilities which are available. And so that is what is the case right now. And of course, our own National Quantum Mission is off the mark, and we will soon see a lot of developments happening. But till then, we have a lot of resources available. and the AI communities and the quantum computing communities, they are working together and building use cases, because as someone said that, it's not only to make India cyber secure, but also quantum secure, because a lot of big companies, aerospace companies, automobile companies, financial companies are going in for making their normal operations. They're getting them, converted to quantum programs, because they know that the moment the thing which is called quantum advantage comes, that means a quantum computer becomes uh, exponentially or maybe more efficient than a classical computer for the same kind of a use case. It is going to be something like Y2K. So the people who are left behind will be left behind. So that's what. So they want to be the early bird, and uh, they are slowly they're converting their use cases into quantum. So having said that, I would uh, request the panelists to tell the audience as to how, in what way can quantum computing enhance the AI's capabilities? Uh, Anyone can answer that, yeah.
Hello. Hi, good evening, ladies and gentlemen. Pulkit Sharma this side. Being a representative of the semiconductor industry, that's where I'll start from. I've been listening to so many people, the panelists, the leaders here inside the auditorium and outside. And most of the time, when we talk about AI, we talk about software. Is it all about it? Not really, I don't think so. Semiconductor is the bedrock, is the foundation of the AI. I was talking to my technology mentor, and he did mention that back in the year 1984 is when he did his first program and certification in AI. So clearly, the concept is not new. But back then, we never had the technology and the power of semiconductor to be able to provide that level of performance to bring it to reality. But with the advancements, we have it, thanks to the likes of CPUs that we have from Intel, to the GPUs that we have from NVIDIA and multiple others, right? So semiconductor is clearly the boss, but it just doesn't end there. It's also reciprocal in nature. So, coming from AI, starting with maybe just the two basic characteristics that we can leverage to grow the semiconductor industry, starting from the predictive um, uh, uh, analysis and pattern detection, which can be utilized, of course, for monitoring, management, anomaly detections, security features, encryption, decryption, basically making them more effective, more efficient, and more secure. But of course, there are always challenges. With more power requires more energy. There are more miscreants and whatnot. But what do we need? We need to look out for the scale. We need to be ready for the scale. So quantum is clearly the boss. Now, why do I say so? If I simply just flip this coin, and when it lands in my hand, I can have just one state. It'll either be heads or tails. Just like a binary bit, either 0 or 1. That's how the traditional compute, the traditional bits work. But how does the quantum bits works? The qubits, I flip the coin up, even while it is in the air, it can have more than one states simultaneously, one after the other, heads after tails, heads after tails. Now, that is the kind of computing power that a quantum system contains. Not just that, if I have to take a real life example, maybe the recent one being Google Willow. They just issued a study that for a particular application and calculation, which the Google Willow can complete, let's say in 5 minutes of time, a traditional bit would usually take around 10 to the power 25. Ladies and gentlemen, that's 25 zeros after one, practically more than the age of the universe. So imagine the kind of power it has. Now imagine if AI is put to use with this kind of computational power in real life scenarios. Be it healthcare, the kind of molecular interaction it can track at the atomic level. There can be drug discoveries for diseases like cancer and Alzheimer's that never existed, for medical diagnosis. And this is live. This is not futuristic that we are talking about, right? So early detection of diseases from the pattern detection of what's happening inside your body at atomic molecular levels again. Moving on to the BFSI segment, the financial segments, fraud detections by identifying patterns again, or even mitigating the risk by analyzing at the very granular level of the patterns of the stock markets and the industry. Same thing in the cyber industry as well. I mean, there are systems today available which can do an anomaly detection at the very data level, right? Imagine for a large set of data for the the global banks of the world, if we can put the quantum mechanics, the quantum computing to the use of it, the kind of miracles it can bring. But what do we really need from where we are? I believe, first of all, the investments from the governments and the private sector companies, right? Investments in research and development so that we make them foolproof and we put these technologies to the utilization of mankind. Second is stakeholder involvement, right? We need to build champions in individual domains when we are looking to solve the human problems. We are talking about healthcare industry, we may need scientists, we may need doctors, so that it just doesn't sound like a new technology to them. They become champions of utilizing of it and at the same time propagating it.
Okay, thanks, Pulkit. I think I'll add to what you said. Quantum computing can definitely speed up machine learning. It can enhance neural networks. It can improve natural language processing capabilities of AI. And it can easily solve optimization problems in a much better fashion than AI, because quantum computers can do matrix multiplication and these kind of things much faster. And it can do parallelism in the sense that for one batch of AI-based LLM given to a quantum computer can spawn hundreds of batches and do the calculations spontaneously. So that is how it can enhance. So I would now request anyone to let us know about the AI-driven quantum solutions in healthcare, finance, cybersecurity. If they can throw some light as to how these kind of solutions can work much better on hybrid quantum systems. I would say hybrid because nothing can work on quantum computers in isolation.
Yeah. So good evening, everyone. I think, let's first look at AI is changing the entire world, and all the organizations, whether for profit, whether hospitals or any other organization, what they are looking for is how do I do things better at a much faster pace, and the quality is better and the price is less. And AI is helping. But what quantum would really do, and as I see, would be kind of doing the same thing at maybe 1,000 times better. So what a normal computer, supercomputer would do, and if I have a 1,000 qubit quantum computer, it will really change the game. Coming to some of the things that you spoke about, for example, all of us drive cars, or we travel by planes. One of the key things over there is how do I reduce weight? Or how do I ensure that the material on which this entire thing is being built, I build a better material? So what companies are doing, and they're spending millions and millions of dollars even on AI, is to get a better material by doing simulations. And you take maybe 100,000 parameters to do simulation. What quantum computing is doing, and there are enough and more people who are working on this, I take more number of parameters. So instead of say 1,000 parameters, can I take 5,000, 10,000 parameters? So instead of this entire simulation taking 1 year or more, can it be done in few days? That is what the real benefit is. Same I take example of, he spoke about the drug discovery from cancer. So all these, I've spent so many years in a pharma company. So there are a lot of things which are being done, and a lot of trials being done, a lot of research being done, but that's only on a limited set of parameters, because the computation, the compute capacity on which it is being done, it cannot really take more than that parameter. And that's what quantum computers would do. As of now, he spoke about 72 qubits. We know that IBM has come with a 1,000 qubit computer, which is maybe a phenomenal, whatever even India has not imagined. We are at 72 today. So those would really change the game. The last piece I'll talk about is on a cybersecurity. He just mentioned, but as I see, quantum computer could be a double-edged sword from cybersecurity perspective. So we might think that in our own organizations we have used huge amount of encryption, whatever we have done to safeguard. But a quantum computer can break all those things in milliseconds, not even seconds. And that's where we need to really work on, and researchers are working on how do we strengthen cybersecurity. So there's a quantum cryptography, for example, people are working on how do I make the encryption keys such that they can't be even broken by a quantum computer. So that's what people are working on. There's a huge amount of work being done. As of now, a lot of it is in nascent stage. A lot of companies are doing POCs. But as I see over the next 2 to 3 years, people will really start developing it. So I'll just stop here in interest of time, Kyle Saab.
Yeah, thank you. We'll have a different perspective from Mr. Shakti, who will give his own perspective about how quantum computers can speed up things, especially in these 3 domains.
Sure, thank you so much. I'd like to give you a perspective from the quantum physics point of view. I mean, when you have to deal with quantum computers, a quantum physicist can write a quantum computing program much better than a regular programmer. And why? There are like 4 things that come into play here which actually make quantum computers faster. One is the concept of superposition, and this is what I kind of was explained earlier. You have this concept of qubits, right? And there is a unique property at quantum level. What does quantum mean? At subatomic level, at very low temperatures, particles exhibit quantum behavior, meaning they can exist in the same state at the same time. If I were a quantum particle, I could be in New York, in London, in Tokyo, or infinite number of cities at the same time. The probability will not be 0. What this means is that when these particles are in a state of superposition, they can hold a lot of information. If you take a regular bit of a computer, it will hold only one piece of information, but under superposition, they hold a lot of information, right, at the same time. The second thing is about entanglement. And this is a unique property in quantum physics. If 2 electrons are entangled with each other, and you can put these electrons at the farthest corners of the universe, if you change the spin of one electron, the spin of the other electron will also change. This is mind-boggling. No one knows why that happens, but that is a property. Now, when you have quantum computers and the concept of qubits, you can have multiple electrons entangled with each other, right? So the amount of information they will store is 2 raised to power n. If n is 300, okay, the amount of information or the number of bits, regular bits that will be required to store that information will be more than the number of atoms in the universe. So with just 300 qubits, if you are able to entangle them, you can store so much information. Now when you do computing, what is it that you need? You need a lot of data, and you are able to process the data faster and be able to consume all this information. If you are going to, let's say, do a molecular simulation, how molecules interact at the atomic level, so much information needs to be stored at the same time that there's not enough memory in the world that can do that. But using quantum computers, you can do that. Then there are like 2 other concepts. One is like quantum tunneling. What it tells you is, when you run an optimization problem, basically you are minimizing the error between the prediction and the observation, right? Now, if you are using a regular machine learning algorithm, you can run only one optimization exercise at any given time. But using quantum computers, and there's something called quantum approximation algorithm, you can run multiple optimizations at the same time. I hope you're able to appreciate that point, right? Otherwise, I'll have to run these optimizations in a serial manner, and that will take a huge amount of time. The 4th thing is quantum annealing. That's another concept. What it does is it tells you what that optimal solution is. You have used all these LLM, chat, GPT, and you get hallucinations, right? You see the hallucination results, you get wrong results. Why? Because these models, they have been trained, but the model parameters have not reached the global minimum. They have reached some local minimum. In order to reach global minimum, you need to run optimization multiple times in parallel and be able to reach the minimum energy state. Now consider how the information is exchanged. You are not going through semiconductors, you're not going through transistors, right? The exchange of information is happening through lasers, right? The information you want to retrieve from a qubit is like through a laser. The information exchange between qubits is lightning fast. That makes the whole thing faster, right? Now when it comes to AI, you have AI, you can run AI on regular computers, you can run AI on quantum computers. The thing is, quantum computers, once again, it's the speed, the performance, and the amount of data it can process. That's the beauty of quantum AI.
Thanks. I will just add on and give you some factual information with which you can have some sort of an idea as to how the world is moving towards the use of quantum computers in healthcare, in fintech. You must be aware of a company called Sandbox AQ, which is a startup from Alphabet, which is the biggest tech company. They employ quantum computing techniques to develop large quantitative models, LQMs, which analyze extensive data sets. And then it has been now taken as a gospel that AI-driven anti-cancer drug discovery is going to happen on hybrid quantum classical facilities only, because this all the panelists have agreed and said that that is going to be the way forward as far as drug discovery and molecular modeling and genomics is concerned. And in advanced medical research collaborations, CAS, which is American non-profit academic medical society of the American Chemical Society, and they have collaborated with Cleveland Clinic to leverage AI and quantum computing for accelerating clinical research. Then most interestingly, Goldman Sachs and AWS, they have collaborated for building quantum algorithms for portfolio optimization. And to go a step further, not only portfolio optimization, but sentiment analysis. The AI is going to do sentiment analysis, and the quantum is going to do portfolio rebalancing. So this algorithm is called quantum portfolio rebalancing algorithm. That means based on the sentiments prevailing at that time, your portfolio will automatically be optimized based on because the sentiment is what is going to drive the stock market. So these kind of developments are happening. And a lot of other financial modeling enhancements are happening. Swiss startup Terra Quantum is utilizing quantum algorithms to improve financial modeling and collateral optimization. Then in cybersecurity, we have all heard what is happening. There is this company called Multiverse Computing and another company, Countercraft. They've built a quantum AI model, and that significantly improves attack detection over traditional methods. Because now AI-based threat-resilient cybersecurity systems have already come in, and we all heard about that. So this is taking them a step further. And trained on the data sets from actual network traffic and system logs. This system is called the matrix product state, MPS. It identifies 100% of the attacks and makes your system absolutely threat-resistant. Then quantum machine learning frameworks are also being used for cybersecurity, etc. Now I would like to ask my esteemed panelists that what will be the hardware improvements and augmentations to give the AI, AI algorithms better compute platforms so that they can do the job faster, because we all know that whatever said and done, quantum computers have still not reached the stage of quantum advantage. They suffer from a lot of errors. The error correction algorithms are not yet as efficient. So therefore, compared to classical computer errors of the order of 10 raised to the power -9, quantum computers still suffer from errors of the order of 10 raised to the power -3. So still they have to cover that gap of 10 raised to the power -6. That is the kind of errors which are there. And the scaling, of course, very difficult to go beyond 1,000 qubits. So what people are adopting now, that you go in for a smaller number of qubits and connect them with optical networks. That's what the next step of Google is going to be, IBM. Instead of going in for higher and higher number of qubits, 139 qubit, I think Eagle processor or something, they're going to build multiple of them and connect them together and use them as clusters. So that's going to happen. So these are kind of developments which are happening. So any other developments which the panelists need to make the audience aware? Yeah.
Well, no, thank you so much. I think the problem of... robotics? Just a
Yes, so
request.
that's what I was coming to. I came in, I was a panelist for not for quantum. Fortunate that I have seen multiple worlds. I worked at Amazon AWS for a long time on the AI side. And I've spent 25 years, 30 years in actually semiconductor chip design, starting with early Power PC, which powered Apple Compute. So I was part of the design team. So I've seen the computation. You mentioned about the computation. And I was also, 1990, my master's dissertation was on neural networks. And I've simulated 5x5 network. And today it's like billions in parameters, right? So the computation has really moved up. So absolutely, I agree with what the panelists have said, that quantum is very promising, specifically because I've been also part of the team at AWS. We had our own, neural computing engines, accelerators like Inference and Trainium. Which obviously competes with our standard NVIDIA GPUs as well. But idea is, so again, there is, and the biggest focus right now on a classical computation is about the balancing between how generalized hardware it could be and how specific you can make it. Because if you have to look at the LLMs, there's a lot of attention computation which happens, a lot of repetitive computation, KV caching happens. So you have to have hardware which sort of can accelerate that. So how much can you be generic versus how much? Because the moment you make it very specific to that, the architecture changes of your LLMs, that's already happening. You have different architectures coming up. So how does the your neural hardware sort of cope up with that? And the moment we make it more generic, it's more programming, so it slows down. So again, that's sort of where a lot of challenges are happening. And the middle layer, which is basically, NVIDIA talks about CUDA. So CUDA, how do you sort of optimize your algorithms from the Python or PyTorch onto your hardware? How do you efficiently map that? So any new accelerator coming in, the software is always a catch up to do, because it can't pick up any random model which you generate and can map it efficiently onto the hardware. That's going to be the challenge. NVIDIA has been lucky because of the CUDA 15, 20 years of open sourcing it. So today you could any PyTorch code to it, it actually be able to do something about it. It may not be most efficiently, but at least it will not barf at you. But if you do a other neural accelerator which is running and you sort of map any random algorithm from PyTorch into that, chances are that it will not accept some of those constructs there and so on and so on. So that's sort of the challenge which every hardware guy, when he's developing the hardware and the neural solution to have. And I think in the next 5 to 10 years, we'll see a lot of improvement, a lot of focus on that. As you mentioned about quantum is a little away, and since you have a lot of panelists right here, one of the things which came in from the Google's common computer is basically when Grok ran through the analysis of that, it actually found a lot of patterns there. So it's not really random. So which means that it's questioning the whole veracity of how accurate would that be. So I want to, if the panelists who are very knowledgeable about this area could shed some light on that, it'll be interesting.
I'll just add 1 second and then, so to your specific question on hardware, so there's a concept called decoherence. So one of the key issues, so qubits at this moment or the quantum state is not very stable, and that's really ensuring that at this moment we can't really have too many qubits. So people from a hardware perspective are working on how do I improve coherence, that the state of the quantum, which is superposition, which Pulkit spoke about, that remains constant. Otherwise it will be like the computer losing its memory. So that's what they are working on, and there are various other things, but in interest of time, maybe I'll just pass it on to you.
I actually did not have nothing to add on to what Anurag was mentioning. It's just that as Anurag and myself both were on the robotics session, and it's good that we've come from the quantum topic, because both are quite interrelated. I'm quite a user or UX first guy, so I'll go top to bottom with an analogy. I spent a lot of time in Scotland, and this is something that many might relate to. Scotland has more sheep than humans. Fun fact. Jensen Huang says that we'll have more robots than humans by 2030, right? Now, if we do that, now what it means for us is that, and the question here is, what are the areas where that would impact us the most? What are the changes that are happening? Everybody is interested in robotics. Everybody wants to have cool robots. NVIDIA and everybody is showcasing them, Boston Dynamics. What the impact that is having on areas like manufacturing and healthcare, where precision is required. And that is the the area where we have made a lot of progress on. Manufacturing has been using robotics for quite a long time now, right? With the advent of Gen AI, now there is a possibility of having robots where their behavior can be modified or trained to our liking, so that it's now somewhat possible and less hypothetical to think about having robotic co-workers. They will be bearable at least, right? Now, as we move on, more and more, so when we have more and more robots in our workplaces, in our daily lives, there would be, you already have robots in malls, they'll start becoming more interactive and less of marketing gimmicks. What will tend to happen is that the ethical side, the biases and all of that, which a lot of the previous talks were about when it came to fintech and all the other, even media, will start playing a large role. Now, if you think about it, a lot of it, there is a lot of data. Do you know how many, so our brains are basically biology and electricity combined together, right? It processes, every second is about 1 trillion synapses. That's 1 trillion operations having, being processed every second. And that is not in isolation, that is against the backdrop of all the data that our brain already has. To process, so for, that's why I said robotics and quantum computing might go or should go hand in hand at least after 2030-ish, is because for that, for robots to actually become useful and for them to behave and operate similar to how a human would, they can have a great LLM, but unless they can process that amount of data at scale and at an instant, robots at least would not be as efficient at human at a lot of tasks. And that's where I think these two topics sort of can merge in a few years. The software part of it first, but the hardware part of it would, I think, take a few years, as the NVIDIA CEO also said. So just wanted to add that point.
Thanks. I think we'll wind up at least the quantum part of it with some last remarks that we are not touched upon the regulatory and the ethical AI frameworks. A lot of them are being set up all across in UK and US and all. And more so, I mean, very welcome thing coming from the Vatican, Rome, the Pope's call, where tech companies like, there is an ethical AI pledge, which they have called people, I mean, the companies to take. And Cisco, Microsoft, IBM have already joined this Vatican-sponsored call for using AI ethically. So I'm sure a lot of companies would join this. And as far as the quantum part, the hardware part is concerned, I just want to add one more thing, that there are a lot of developments happening in the processor, the quantum processor architecture, where 3D architectures are being experimented with. Quantum gates have to use qubits, and these qubits have to be entangled. So to increase the entanglement over shorter distances, the 3D architectures and multiple dimensional architectures are being thought about. And so therefore, that is one very big revolution which is happening, other than the error correction and other initiatives which are taking place. So as Dr. Chaudhary earlier in his keynote address said, developments are happening in leaps and bounds. And we need to literally, I mean, catch up very fast with the world as far as hardware development is concerned. As far as other aspects are concerned, we are well on our way. So with that, I will end the quantum
Actually, one thing I wanted
session.
to mention about the hardware point was, you know, we like talk about qubits, coherence, decoherence, errors in computation. But there is another area which is undergoing rapid development, or which needs research, is how do you extract information from a qubit and like convert that to classical data?
Yeah.
You know, there's a concept of quantum feature maps.
Yes.
So that thing has to be researched into, and like that also needs optimization. That's part of hardware learning.
I'll just also add one more thing. So AI perspective, there's a major issue of bias and hallucination. And quantum can really help in that, because you can do so much of more simulations and avoid that. So from that perspective also, quantum will help grow AI in a big way.
Thanks. So I'd like to thank all my fellow panelists and hand over to Mr. Sanjeev Kumar Chaudhary, Senior General Manager Engineering, HUDC Power Grid.
Good evening, gentlemen. Myself is Sanjeev Chaudhary. Actually, in my place, my executive director Suvir Sen has to come. However, he was busy in some meeting. Therefore, I have to come here. Now, my topic is here for because we are related to power utility. Is power transmission. We are doing high voltage transmission up to 765 kV, or planning for 1200 kV in AC system. And also we are doing HVDC in 800 kV. Definitely AI, initially we are forming digital system. We are focusing more on digital. Now we are focusing more AI, now also in robotic systems. In briefly, before going to discuss in detail, just I will tell you about our power grid transmission system, which is very important for the country, for India, which is also connecting with the cross-border country like Bangladesh and other. Also, we are planning to connect other international. So, if you talk about power grid, we have approximately 1,80,000 kilometer circuit kilometer transmission line. Transmission line, I mean to say above 220 kV above. And approximately 280 EHV substation, means 220 kV and above, 220, 400, 765 and 800 kV HVDC also. If you see our transformation capacity, around 5,51,961 MVA transformer capacity. And also we are planning to add in next 4 years approximately 2,90,000. And total, if you ask our assets I mean to say equipment covered in our transmission system is more than 5 lakhs. And now I will talk about the data which are dealing with for analyzing the faults and also for performance and rating everything in TV. Approximately 15 TV we are taking the data, and if you compare the node, there are more than 2,90,000 towers is there, where we have to use AI to find out their performance and their structure, any damage, any issue is there. So why we need an AI ML in our transmission systems? If you talk about the data, especially in technology, which technology we have to use, innovation and business also. So the basic purpose of AI ML in power grid, I will say, basically centralize in the digital data and application of data governance for philosophy. For robotics, I will call my Mr. Ravi is there. He is sitting with me, is my colleague. He will explain you how we have developed one robots where we can do, because in substation, if you think is very big substation, if you employed the person, there are a lot of manpower required, but by considering our robot development, we can reduce so much of times. So we have developed robot for our substations. And also we are Power Grid is planning to develop robots in various, also used in construction, where we are going for high mountainous regions, high altitude regions, where difficult to locate the manpowers. So there are a lot of challenges there. So that's the one example we will tell you, how robot, what we will do in robot in our substation, just because our Ravi is involving, so therefore he will explain you, sir.
Good evening, everyone. Myself, Ravi Sushant Chaudhary, and I'm Deputy General Manager in Power Grid Corporation of India. So I will divide this thing, the AI application in power utility, in 3 parts. First of all, we don't do anything which we don't need. So there has to be need. So we started in 1992 with 25,000 gross capital. 25,000 gross capital. Now currently we are having more than 3 lakh crores of gross capital. And we're going to reach more than 4,50,000 gross capital in the next 3 or 4 years. And we have same resources. So same 8,000 employees who were managing 25 substations are now managing 292 high voltage, ultra high voltage substations. So for these, you have to optimize the resources. So there is no other option. You don't have a magic wand wherein you can create trained manpower within 2 years or 3 years. So definitely you have to take the help of technology. Now, how we are using it. So this is the need that we are going for it. Now, how we are using it. We have various applications of AI, ML in power industry. Especially, as SRS told, we have more than 290,000 towers, which are widespread all across different locations in India. It starts from Ladakh and it ends at Kanyakumari. And there are so many cross-border connections. So there are so many geographical challenges where normally people cannot frequently go for patrolling. So therein we have implemented AI ML solutions with the help of deep learning to find out the defects of the towers. So basically that is indigenously developed by PowerGrid with the help of my colleague, Mr. Joseph, who's here. He has indigenously implemented that solution, and that has been awarded by, globally also, wherein we capture the, we take the images which are captured by the drone from the different angles with different backgrounds, and also the images which are captured from the top and the bottom. So you have to make a huge cluster of images wherein you can identify the given defects, and those defects are being learned throughout the years with multiple data sets. And after that, you come out with the 36 defects, type of defects, which a human eye normally may not be able to capture. So that has helped us a lot. We have been able to minimize our outage by more than 60% with the application of AML in tower defects. In addition to that, we have reliability-centered maintenance, because earlier what we used to do, we used to maintain an asset. Like we have more than 5 lakh assets. So those 5 lakh assets basically produce more than 10 data points in a fraction of a millisecond. So you can imagine how much we have 15 TB of data set. So it is not possible for a human to analyze all the data sets and evaluate the health of the equipment. So we are having near to real-time health of an asset with the help of AI/ML. What we do is that all the signatures which are captured, like DCRM, like timing, all the inputs of the maintenance and the visual inspection, they are captured in our tool, which is PALMS. And that tool, with the help of given criteria, we evaluate that data set. And ultimately, we are able to evaluate the near to real-time health of the assets. So with that, currently, we have implemented that solution for transformers and the breakers, which is the most critical assets of our substation. In addition to that, how AI/ML helps us? AI/ML helps us. It is not going to replace the human beings, but it is going to aid us with a solution that we already know. So we are not going to spend our resources for the things we already know. So for the substation inspection, we have developed a substation robot with the collaboration of IIT Kanpur, wherein that substation robot is programmed to survey all our equipments within the substation, and it is going to monitor the near to real time the temperature, the OTI and WTI graphs, the other parameters which are normally captured by the human inspection. So that is being done by a robot that has already been implemented and successfully done in our case. Also, it is also going to check the minor leakages and the health of the bushings and the health of the transformer and report it directly in the system. In addition to that, we have also, with the application of AI/ML, we have also reduced the human interface. Earlier, what we used to do, we used to capture the data and record the data in the registers, and then we were supposed to put the data in the ERP. But what we have done with the help of AI/ML, we are capturing the data from the testing kits directly, and it is going to ERP directly. So human intervention is minimized, and the last and most important thing, there are certain challenges with AI/ML also. So what we need to understand is that—
Can I request you at the behest of the organizers to please wrap up?
Sir?
Can I request you to wrap up, because there are some other questions for robotics?
Okay. So my final word is the challenges. So with the technology, we have to go through the challenges also, and we need to understand that how we are, judicially apply the various AI tools to the benefit of our organization. So I think this was all about our AI application currently, and our management is in PowerGrid is committed to have a complete digital transformation with the help of AI. Thank you.
Thank you, sir. Basically, the purpose is challenges associated with the power grid because a lot of assets is there. So definitely there is a technical challenges, especially computing, because a lot of data is generating. Especially all the technology we are developing in-house, hoping that skill manpower and also our collaboration with IIT and help this critical and reliable grid to the India, sir. Thank you, sir. Thank you very much, sir.
So I think this mixed session on quantum and robotics now concludes. So thank you very much for a patient listening. And thanks to the panelists for sharing their views, expert views with the audience. Thank you.
May I request Mr. Raj Sharma to kindly come up on the stage while we move on to our next session. But before we do that, thank you so much for sharing these insights. We'd like to present a memento each to all our distinguished panel.
Semiconductor and robotics.
So may we have the first brochure. I mean, the memento to Colonel A.K. Nath, Senior Advisor Quantum, HPC Technologies. And he was a kind moderator also. Colonel A.K. Nath, Senior Advisor Quantum, HPC Technologies. Mr. Vijay Sethi, Chairman and Chief Mentor, CART. Mr. Vijay Sethi, Chairman and Chief Mentor, CART. Ma'am, please, can we have Mr. Pulkit Sharma, CTO, Dell Technology. Thank you, sir. Mr. Pulkit Sharma, CTO, Dell Technology. Dr. Shakti Goel, CTO, Yatra Online. But first, Mr. Pulkit Sharma. Can we have a big round of applause, ladies and gentlemen? And now we have our other awards. Mr. Shriban Banerjee, Founder, Chief AI Officer, Zaira and Rashmi Group of Industries. Mr. Anurag Seth, Principal AI ML Advisor, Amazon Web Services, AWS. Mr. Sandeep Chaudhary. Mr. Anurag Seth, संदीप चौधरी जी सर थोड़ा तालियां बजा दीजिए। एक बच्चे के फंक्शन में मैंने देखा स्कूल में एक शेर है डॉक्टर साहब, डॉक्टर विवेक गुप्ता, एक बच्चे ने, छोटे बच्चे ने स्टेज से पढ़ा कि संतरे से निकले उसे जूस कहते हैं और जो ताली ना बजाए उसे कंजूस कहते हैं। बजा दीजिए ताली प्लीज। थैंक यू। हाँ सर, एक देखिए कहा संतरे से निकले उसे जूस कहते हैं, जो ताली ना बजाए उसे कंजूस कहते हैं। कोई बात नहीं, but thank you. It's really an honor, you know, you have graced throughout this morning, and this is a very, it encourages all of us at AICRA to celebrate the vision, to translate it better. And it's a continuous process. We keep on improving. Thank you, sir. We'll just quickly have a photo up here while we move on to our next session, which is primarily based on